Hey everybody, today we're going to talk a little bit about soldering. This is something we do in the makerspace at the Vestavia Hills Library from time to time. We have certain programs that require a little bit of knowledge about soldering. So first off, is it soldering or soldering? Well, if you're in the US, you're probably going to say soldering, solder. If you're in the UK, you might say solder. I'm going to say solder because it's what I grew up with. Here's a few of the tools we're going to be using. We have the soldering iron and soldering stand with a little bit of damp sponge. We have solder. We've got the solder sucker for removing solder. We also have braided copper wire for removing solder. We have the helping hands station for holding our work in place. And we have the fume extractor. So let's talk a little bit about safety. The fume extractor is pretty important. When you're soldering, the solder and the flux inside the solder lets off a lot of fumes. Pretty toxic stuff inside it. So you want to turn this thing on and it will suck the fumes, the smoke, away from you and filter it. So you'll be breathing more healthy air. And one of the more obvious things is the soldering iron itself gets really, really hot. You see this one's turned up to 450 degrees Celsius. So that's hot. And if you were to take the soldering iron and let's say you touched your finger with it, and instead of my finger, I'm going to use this here vegan hot dog, you'll see it wouldn't feel too good. You see the smoke and the char marks there. You wouldn't want to touch your skin with that. So make it a point to keep your fingers away from the soldering iron, and just safety first. You know what I mean? So the helping hands tool is just invaluable for holding your workpiece in place, otherwise you'd be burning yourself. And I think what this finger is indicating is that this resistor is bad. So it's going to be what we need to take off of this circuit board here. And the back of this circuit board is not too great either. These little joints here look pretty terrible. Whoever did this was a maniac. Yeah, just look at those globs of solder there. We'll have to take this off, remove the solder, and replace the bad resistor in the circuit. So we're gonna start by heating up these 2 points with the soldering iron, and then we're going to first try sucking the liquid solder once it melts with the solder sucker. And there, got some there. And it just sort of pops it out when it's dried or cooled. Suck some more out there. Pop it out. And we melt the solder with the soldering iron and then sucked it right out. And as you can see, there's still a little bit of solder still stuck to the wires. So I'm going to get this copper braid, and you just apply heat to the braid over where you want to get the residue of the solder, and the solder just kind of wicks itself up into the braid, and you can clear off a lot of the remainder like this. You just get a new section of the braid every time you want to pull up a little bit more solder. And since it's copper, it's going to conduct the heat of the soldering iron very, very well. In here, I'm using a set of tweezers to pull the leg of the broken resistor out through the hole, because you have to remember, whatever you're heating with the soldering iron, if it's metal, it's going to heat up too. So pulling this off with my fingers would not really be a smart idea. I'd burn myself pretty bad. And after I've gotten the bad resistor out of there, this is what it looks like on the other side, and I want to put the new one right there. where those two holes are going to meet up with the red wires. So I'll take the new resistor and I'm going to bend the legs with the needle nose pliers at an angle there to where it'll go straight down into the board. And we'll just set it in place right next to those red wires, because we're going to solder the points between the leg of the resistor and where the wire is going into that hole. Just turn it over to where you can see. The legs of that resistor are coming out the back. And so we'll bend the legs of that resistor a little bit outward so that it won't fall through as easily. Now that they're bent, we'll take the soldering iron, and you want to touch the legs of the resistor and the point on the circuit board, but not necessarily the solder. You don't want to melt the solder with the iron. You want the solder to melt onto the component and the board, because they have to be hot enough to melt the solder so that they'll bond. Really, you should just touch the point for a second or two with the soldering iron and then touch it with the solder. And it should, if the iron's hot enough, it should melt to the component wire and to the board. And then release, because you don't want to damage the component with a lot of heat. Now, as you can see, I'm not really taking my own advice here. I'm just trying to make a solid connection between the component leg and the board. I'm not doing the best job here. This is my first time, so, cut me a break. Not my first time soldering, my first time videotaping and soldering at the same time. So yeah. Practice. Practice makes perfect. And I did not practice. And after snipping off the excess of the leads with these pliers, our circuit works. Look at it go. Blinking, blinking away. So I hope you learned something. I know I did. Join us in the makerspace when we open back up. Try not to burn yourself. Thanks for watching.